Think math.
Let us find the mean blood type of our class. 12 type A, 8 type B, 9 type O, and 1 type AB. Add them all up and divide by the number of people, and what comes out? Nothing comes out because they cannot be added in the first place. But can you say exactly why? Compare what each of the three demands of the data. The mean needs values you can add and divide. The median needs values you can put in size order. The mode asks for far less. It only needs to tell whether two values are the same or different. Different demands mean different data can be handled. Start with adding. What is red plus blue? You may want to say purple, but that is mixing paint, not adding data. Type A plus type O is no better. Once addition has no meaning, there is no way to build a mean at all. What about the median? It needs no adding, so it looks promising, but ordering requires deciding which value is greater. Is type A greater than type B? You can impose an order by force, but choose a different order and a different blood type lands in the middle. The answer would depend on whoever chose, not on the data. That is not a median. Only the mode survives intact. Type A is the same as type A, and different from type B. Knowing only that, you can count how often each value appears and take the largest count. No adding, no ordering. Because it demands the least, it works on the widest range of data. So, choosing an average is not a preference. It is a question of what the data permits. If it can be added, the mean is available. If it can be ordered, the median. And if values can merely be told apart, the mode. Next time, why a mode can come in twos or fail to exist at all. See you in the next one. A sip of math every day here at Think Math.